So today we are going over tangent and cotangent graphs. And this is going to work very similarly to secant and cosecant with a few, I'd say, significant differences just because the graphs are quite different, but the process is going to be similar. So first off, let's talk about the essential or the general equation. That hasn't changed. Y equals plus or minus A, and I'll just do tangent for this. Tangent of B times x minus the phase shift plus the vertical shift at the end. So again, the equation's the same. We are looking for the same main three variables first because those variables don't change from one equation to the next. Those are A, B, and vertical shift. So again, we will start our problem by finding those three first. First, let's talk about finding the midline of this graph. For tangent, cotangent graphs, finding the midline can be difficult because as A increases, the graph gets a bit skinnier and more vertical, and that can be really hard to identify where that middle happens. So you have to eyeball it at first and then kind of use your best judgment from there. We're not going to throw any crazy A values at you for that reason, but just something to be aware of. So since this is a disco right graph, I'm going to use that for kind of my reference. The midline will go through where the shape changes. So just kind of a little background here. The bottom shape here where it goes down, we refer to that as concave down. Not important to know now, but if you're going to calculus, you will hear that term at some point. And then the part that curves upward, that's called concave up. So when it switches from one shape to the other, from down to up, that's where you're going to find the midline, again, where the shape changes or where the curve changes. So again, I'm just going to give a little background on that. Midline is where the curve changes shape. On this graph, it's a bit easier to tell. There are some other graphs I'm going to give you where it's not as easy, so just kind of keep an eye out for that. But here, we can clearly see the shape change right about here. And again, you can kind of pinpoint there where that midline is going to happen, and it's at -2. In fact, the y-axis kind of is a good indicator here where it cuts it, where that shape changes. So the midline is going to cut through the middle of these curves at -2. This is our midline, which, reminder, is also the vertical shift. Since it's through -2, our vertical shift is down 2. So I'll fill that in below. Next, we find A. This is a bit more challenging for the tangent graph versus the other ones we've discussed. What I want to do before I find it is draw in all the extra details that would be drawn in if I were to graph this myself by hand. So first, let's start with the asymptotes. Again, you kind of have to use your judgment here. But let's look at these two curves in the center here, one going on through the y-axis and the one to the left. The curve on the right ends here, and then the curve on the left ends here, and the curve on the right ends here. And in between them, there's this singular line in the middle. This is clearly going to be the asymptote. This hasn't been a major issue, but some students have struggled with it. This isn't always going to be the case where it's the next line over. It's the line in the middle of the two curves that you're looking at. So again, you might have to use your best judgment there, kind of thinking about it before you mark where that asymptote is. Make sure it's in the middle of the two curves. This case wasn't so hard to find, but others, again, are going to be a bit more difficult. From here, we can draw in the rest of the asymptotes in the graph. Next, I want to find the other 2 points that get graphed. So all of these curves, I already have the center point graphed, but then the one up and the one down, I need those in order to find my A value. For that, I'm going to pick a curve to single out. So that's going to be the one in the center here that goes through the y-axis. I'm going to zoom in a bit here. Reminder, this would be considered an easier graph compared to some of the other ones you're going to see, so keep that in mind as I go through this. We need to go one interval left and right to find those other 2 values. So the point that's halfway between the center and the asymptote on the left, again, there's only one interval to choose from. Other problems, there might be 2 to 3 in between there. You're going to have to go in the center of that. Same thing on the right side, there's only one other interval to choose from there, so that's pretty easy. If not, go in the middle of those 2. To find our other points, we're going to meet the graph at those notches. So on the left, I'm going to go down to meet the graph to find the point downward. And then on the right, I'm going to go up to meet the graph to find my next point up, creating that stretch. Now I can clearly see that my A, if I go up or down, is 1. Lastly, my B value. Ironically, B, in my opinion, is one of the easiest things to find here because it's much easier to find a period of a tangent or a cotangent graph. Let's talk about that. When we first learned to graph these, I told you that you can always know you have a period because a period on tangent or cotangent is what to what? What feature on the graph measures out one period? Yeah, asymptote to asymptote. So any of these asymptote to asymptote distances, that's one full period. So we're looking at 1, 2, 3, 4 full curves on this graph. You can pick any of those to measure the period. Again, some places are easier to start than others. Now we can't cheat and start at 0 here because the curve cuts through it halfway at 0. So we are going to have to do the calculation by hand. Since I've already marked up the middle curve, I'm going to use that to find the period. So looking at these asymptotes, on the left here, this asymptote, get a little closer here. We've got the y-axis, which is 0 for x, and negative pi on the left. We don't have the middle value. But remember, this is just halfway between 0 and negative 1, which is negative 1/2 pi. Or negative pi over 2, your preference on that. And then the other asymptote is going to be the same thing, but positive. We have 0, and this is pi that's given to us. So this is 1/2 pi, or pi over 2. So this is 1 period. And again, we know that because it's asymptote to asymptote. So these are very easy to identify compared to the other ones. And then we need to calculate that period. So remember, the calculation is the right minus the left. That will always give you the full period, even if there are negatives involved. It'll take care of those. So to find our period, the right is 1/2 pi minus the left is negative 1/2 pi. Write both negatives down so they'll cancel. And then, of course, this becomes a plus, so it's basically just a half plus a half. And if we want to go further than that, 1 plus 1 on the top, we get 2 over 2 pi, which is just pi. Our period is pi. Questions on finding the period? Okay. Next, the whole reason to find the period, again, is to find the b value. So now that we have the period, we can find b. For b, we use the formula period equals, reminder, tangent cotangent's a bit different. It's not 2 pi over b, it's what? Just pi over b, thank you. Make sure you remember that. It's going to be a big theme on the test. Period, we drop that down. We now know it's just pi. Pi is equal to pi over b. And to make this also a fraction, we'll drop a 1 under that pi. Without doing the work, I hope that you can see that b has to be 1. That's the only way that this will work. If you have 2 equal fractions and the tops are the same, the bottoms must also be the same. So I'm going to skip the work on that part. B is 1. Questions on finding the 3 essential variables? Let's start building our equations. Again, I can build them simultaneously. Y equals, we'll start with the tangent equation. A is 1, we found that. Leave space because we need to determine if it's positive or negative 1. Tangent of B, which is also 1 here, times x minus our phase shift. That will be determined when we find a starting point. And then our vertical shift is -2 at the end. I'll do the exact same equation, but for cotangent. Y equals 1 cotangent 1. X minus whatever the phase shift is, -2. And again, we need to fill in those unknowns in a moment. Let's start with the tangent. When we graph tangent, its starting point is always which point on the curve? Which point on the graph of the tangent curve do I always put the circle around? The center. So any of these center points are the start of a tangent curve. This is a tangent graph fully because of how I have chosen it. It goes through 0 on the x-axis. So the one I've already marked up will do. I'll use this as my phase shift. I've already conveniently messed with it. So this is my phase shift for tangent. My phase shift is 0. And again, that's for my tangent graph. So my phase shift is 0. Positive or negative? Is it reflected or not? This shape is disco right. It's going up to the right. Which graph has the disco right shape, tangent or cotangent? Tangent. So reminder, tangent is supposed to be disco right. Since that is correct, this is a positive. There is no reflection here. It goes the correct direction. I'm going to go ahead and note that cotangent is disco left. Since it's not disco right, it's disco left. We'll revisit that point in just a moment. Let's clean that equation up just a little bit. Y equals, I can drop the positive 1. Tangent, I can drop the 1 for B. X, I can drop the 0. Minus 2. It's actually quite a simple equation. There's not much done to it. This is our first equation. Second equation, cotangent. We first need to find a starting point. Cotangent does not start in the middle of the curve. Where does it start? On the asymptote. So in the asymptote, pick one. That is a cotangent starting point. Now, keep in mind, we don't have all the numbers for the asymptotes, so I would just kind of think about that when you make your decision. We do already know 2 of the asymptote values, so either one of these would be good choices. I chose the left one earlier, so I'm going to stick with that. I'll let this be my starting point for cotangent. That's my phase shift, and it is negative. I'm going to write pi over 2. You can also write 1/2 pi. It's still correct. Negative pi over 2, again, that's for the cotangent curve. So I'll fill that in above. Lastly, we need to address whether the A is positive or negative. We've already established that disco right is the tangent shape, cotangent is disco left. The entire graph is disco right. There is no way that we can have both shapes coexist in the same graph because it's just copy-paste the entire time. So we can't ever force one of those curves to become a disco left. So what does that mean for our A value? It's negative. Something really important to notice, when you have tangent and cotangent equations that you're making, one of them will always have a reflection. Because again, the graph can only go one way the whole time. So if you have tangent curves across the board, your cotangent will have to be a reflected equation. And vice versa. If you have a disco left curve the whole way, your tangent equation will be and have a reflection. So that's something to always keep in mind when you make these equations. One of them should be reflected, always. Let's clean this up a bit. Y equals, I have to keep the negative, but I'll drop the 1. Negative cotangent, I'll drop the 1 for B. X, clean this up, do not ever leave minus negative, plus pi over 2, minus 2 at the end. And again, make sure one of these equations has a negative in front. If you're making one tangent, one cotangent, one of them must be negative. It's not possible for that not to happen. Questions on this first example? For our second graph, notice that specifically it's going to be a little harder because it's a little skinnier. So the A is not 1 here, I can tell you that much. I am actually going to leave you guys to do this one on your own, and I will go to you guys individually to check your equations when you're ready, and if they're good, I'll give you your homework assignment. Time is yours.